Newman puzzle from yesterday. This one's called In Umbra Pugnabimus. Pugnabimus. Okay? Normal Sudoku is applied. We have XV pairs. Got that. And then we have arrows. They're just long arrows must sum to the circled cell. Okay, so this, let's see, if this were a 6, then this would have to be a 4, which would these would both have to be 1s. So it can't be a 6. All right, so we're just going to use 6, 7, 8, 9. No, we know it can't be a 9. Now it cannot be a 6. So if this were a 7, then this would have to be a 3. And if that were a 3, then we would need... No, okay, so this is an 8. So that's a 2, that's an 8. Then this is also a 2, so that's an 8 as well. So then this is equals 6, so 1, 5, or 4, 2. So it has to be, no, wait, yeah, 1, 5. So this is a 1, that's a 5, so that's a 4. I think. Okay, so we can do the similar thing over here for this side of the arrow. So 6, 7, 8, 9, that cannot be an 8. So this, so it'd have to be a 9. So that's a 1, that's a 1, that's a 9, so that's a 4. So what else do we have? Okay, so this again could be 6, 7, 8, 9. Can't be 8, 9. It cannot be 6 because this would be a, actually, yeah, no, it can't be a 6 because this would be a 4 and a 2, but there's already 2. So this is a 7, which puts this as a 3. That's a 4, so that's a 2. And then this is going to be a 2, 4, right? Yeah. And then that's an 8. So we put 3s over here, 7s, and then 5s. Okay. These are 8s. And then so are these. And then these are the 8s because this 8 is good, takes care of that. And then an 8 cannot be on a V, so this is an 8. So this is again a 6, 7. So this is going to be a 6 or a 7. This can be a 6. And then this would be a 4. So there's definitely a 4 here. Because if it were a 7, then there would be 7, 3, 4. Okay, that's fair. Which puts a 4 down here. Love that. Then we need an 8 in this column, so it goes there. What else do we need? We need a 3, 6, and 5. So the 5 is going to be here, and then this will be a 3, 6 pair to add up to 9, which puts a 6 here. And then this becomes a 1, 9? Yeah, 1, 9. So I have a 1 here. 2s. 3's already there. 4. Then we can do 5s are here. 6 is already there. 7, 8, and 9. Okay, that's fine. I'm okay with that. So what is this going to be? So if this now needs to add up to 8. So it cannot be, it can't be a 2, 7. Can it? No, 2, 7, no, because 2, 7 equals 9, and we're trying to add up to 6. Or 7, I mean. No, 8. What am I talking about? Can it be a 2, 6? It could be a 2, 6. Could it be a 3, 5? 5, 3? Looks like it. And then that's as high as it goes. So that can't be a 2, so that can't be a 6. 2, 3, 5, 6. 5 and 3 is 8, 6 and 2. Okay, I think that's correct. So then this would be a 2, 3 as well. 1, 2, 3, 4. So then 5s, 6s, 7s, 8's already there, and then 9s. 5, 6, 7, 8, 9. Okay, I think that's right. So this is either a 1, 3, or a 1, 4. Either way, the 1 is here. 9. So then this is 3 or 4. I think that's right. All right, but this is right because that's a 6. 2. So then we need 3, 7, 9. 3, 7, 9, and then this cannot be a 3 because this limits it. So then the 9 is there, so then this becomes a 1. That's a 9. Then we can pencil mark in. Actually, let's just solve that 6 while we're at it, and then we can pencil mark in the 1s. And we need 1, 3, and 7. 3 and 7, and then this cannot be a 7 because we need a 1. So this is a 3, which puts this as a 5. So that's a 4, and then that becomes a 7, which puts this as a 3, that's a 4, so that's a 2, 2, 3. That's a 5, 6, 3, so we have 2, 7, 7. That's a 6. 7, 1, then we need 2, 4, so 2 and 4. Let's clean up a little bit. Okay, so down here, this is the 1, 2, 3, 4. This will be a 5, so will that. And then we need a 6, 9, nice, 9 and 6. 1, 2, this is a 5. So we have 3, 5 over here, which can put a 3 here and a 6 here. Then we need a 3, 4, 4, 3. So the 3 is there. All right, this is a 1, 2, 3, 4, 5, 6, and 9, which puts 7 there, 9 there. Then we have 8, 7, 9, 8. Then we need 2 here and 7 there. Nice. Nice work, Philip.